Okay, so my name is Meredith, and I am here to talk about a web framework called Anvil, which is for building full-stack web applications entirely in Python. So, and that I really do mean entirely in Python. So not just, sorry, AV issue. Get me back to the correct Chrome window. Thank you. Not just in terms of a server-side web framework, but really we're talking the full stack. So we write Python that runs in the web browser, Python that runs on the server, even a Python user interface toolkit. And I would forgive you if your first question was why? And to really answer that, we need to talk about the web. Because I will maintain that the web is really quite a developer-hostile platform. I think about it from the perspective of a piece of data in your web application. So in a traditional web application, your data is probably going to start as rows in a database table, accessed by SQL commands. But you're not going to leave it there. You are going to pull it out. You're going to transform it into objects in your server-side code, probably Python code in present company. And those are accessed by methods and attributes. And then you will immediately re-render those as JSON delivered over HTTP with a REST API with this weirdly limited set of verbs like get, post, put, delete. But on the other end of that HTTP request is JavaScript code, which will reassemble it into JavaScript objects with its own methods, its own attributes, and then turn around and render that into HTML DOM with an idiosyncratic API all of its own, and then use like a rules-based language to render that into pixels. I mean, that is a lot of representations. And indeed, most of the day-to-day work of web development is the work of translating between these different representations. And that work is tedious and repetitive. And we all know what programmers do with tedious and repetitive tasks, which is we set out to automate them. And that creates incentives for really the wrong kind of magic. What do I mean by the wrong kind of magic? Well, let me explain with a totally unfair potshot at SQLAlchemy, which some of you may be familiar with. If you're not, it's a library for automating the conversion between rows in a database table and Python objects. And it's actually a really cool library. It means that instead of writing SQL code like this, you get to write Python code like this. Query filter book.price is less than 20. Well, that's nice. It means that you've not had to change languages in the middle of your database query. You can get these things back straight as Python objects. But of course, the machinery that turns that expression into something that you can run against a database is black magic. We're talking meta classes, we're talking operators overloaded to do something completely different to what they normally do. And if you mess with it, you're going to find that out the hard way. If you start treating that book.price is less than 20 as if it were a numerical comparison, you're going to come unstuck because it's actually an overloaded operator that's returning an object, arbitrary bits of internal SQLAlchemy that's going to be used to generate source code in a different programming language. And once you, in order to become an advanced user of this, you do actually need to be able to deal with this. You want to generate efficient SQL, so you need to know about how that generation happens. And what this results in is a situation where you need to know about Python, and you need to know about SQL, and you need to know all about how SQLAlchemy does the transition. And that, so you gain some speed of execution, or writing your code, but you cost yourself a fair bit of complexity. And you could probably get away with this if you did this, let's say, once or twice in your stack. But of course, we don't just do that. We've got ORMs like SQLAlchemy helping us turn database tables into objects. We've got REST frameworks helping us turn those objects into JSON over HTTP. We've got JavaScript frameworks on the other end, like Angular's resources, helping us reassemble those into JavaScript objects. We've got templating engines like React, or possibly Ginger 2, or possibly both in the same project, helping you turn those into HTML DOM. And you've got CSS frameworks like Bootstrap helping us to render those into pixels. And all of those orange boxes have those same problems. They're all twisting one layer, one of these blue representations, in order to represent an adjacent layer in the stack. And that means that in order to use the web, you need to understand everything in the blue boxes and everything in the orange boxes. We're Pythonistas here. How does that stack up against PEP 20, the Zen of Python? Here's a famous saying, simple is better than complex. Well, that was not a simple system, right? There were, more moving parts than I can count on my fingers. So of this famous set of sayings, let's pick another one. If the implementation is hard to explain, it's a bad idea. The inside of a JavaScript framework is famously gnarly. And worse, if you're using something like React, you actually end up having to understand quite a lot about how it works underneath. Oh, here's a famous one. There should be one and preferably only one obvious way to do it. Ouch. So if we look at the web, we see a developer-hostile environment that requires you to understand enormous numbers of languages and a ton of frameworks in order to get anything done. And if your background, like mine, is in building usable programming systems, then you look at this kind of Frankenstein of a development platform and you think, could we do it better? And of course, spoiler alert, I am here presenting because we've had what we think is a pretty good shot at that. So the key insight here is that just building another web framework won't help you. Because if you swap out one of these orange boxes for something else, swap out Flask for Django, swap out Angular for React, it doesn't solve the core problem, which is that you need to understand everything in all of these boxes. And if you make a better framework for translating between them, you still need to understand everything else. So we went, okay, the problem is clearly in the translation between all these different layers of your stack. So what if we could remove all of this translation complexity and put everything into one representation? And the representation we chose is the Python programming language. So what I am going to be showing you today is a framework with a user interface toolkit that's in Python, where you write Python that runs in the web browser so that when it's driving its user interface and making messages appear and so on, it's not generating source code in a different programming language, it's manipulating Python objects. Python on the server, obviously, but once you've got Python on the server and Python on the client, you don't need to mash all your data into JSON anymore. You can just make a function call. We've even got a Python native database that represents rows as Python objects, which means that you can pass your data all the way from the database to the user interface without having to change its representation. And what that adds up to is, I think, a framework where it's really quite straightforward to get things done quickly. Now, that's the theory. What I'm going to do now is I'm going to show you a demo, I'm going to build an application in front of you. And then we're going to walk through what I just did. And we're going to dig in behind the scenes, look at how it was put together, how it works, and finally, look at some of the design philosophy that embodies what you're about to see. But let's begin. Right. Hello, world. New camera working. So I am currently in the Anvil editor and I am creating a new application. This here is my web page. This here is a toolbox of things I can drag and drop into that web page. So to, let's say I want to put a message in the title bar. I can take a label, I drag and drop it in, and then I can edit its properties. So I can say, hello Orlando Pie. And that's how I put some text on the screen. All right, let's be a little bit more fun and interactive. What I'm going to build now is a Hello World application where you enter your name and it greets you by name. So let's put a card onto the page, and then we'll put a label in here to prompt the user to enter their name. I'm going to add a text box so they can answer that question. I'm going to call this name box. Everything in Anvil has a variable name, so you can access it from code. I'm going to add a button for them to click when they're done. I'm going to say hello. We can make it a little bit more prominent. And you can see what's going to happen. They're going to enter their name, they're going to click the button, and a message is going to appear. So the final thing we need is a label here for the message to appear on. I'm going to call it message label because creativity is a sin. We can change some other properties here. So let's make the text center aligned. We can make it big and so on. So I've just built the user interface, and obviously that's an awful lot faster than it would have been with HTML and CSS. But the really cool thing is all of this is backed by Python. So if I double click this button, I'm now editing the Python code that runs when this button is clicked. And actually, I might want to zoom in here because I don't know how much resolution you guys are getting. OK, and you can see all the things I dragged and dropped onto my page are available as Python objects in my code. So if I want to change the text on the message label based on the text that's put into the name box, I can go, clicking helps, self.messagelabel.text equals hello self.namebox.text. And that's it. If I run this application, I now have an application that's working and interactive in my browser. So I've just built a web application with nothing but Python, and oh, it's not actually on the web yet. Let's fix that. Let's make it a public link. So hello-orlandopie.anvil.app. Okay, so you could go right now to hello-orlandopie.anvil.app, and you will see this application live on the web. So I've just built and deployed a web app entirely in Python in front of you. Now, that was all very well, but of course, actually everything I've been, everything I've done so far is running in the web browser. So this Python code actually gets compiled to JavaScript and runs in your web browser when you open this application. Now, this is great for snappy UI responses, but obviously any serious application is going to need some server-side code as well. And to do this, I'm going to add a server module. So this is a Python module that runs on the server. This is a perfectly ordinary Python module with a perfectly ordinary function. But what I can do is I can tag this function anvil.server.callable. And what that means is that this function can be called from the browser. So if we go back into our browser code, when the button gets clicked, we update the user interface, but we're also going to call anvil.server.call, that say hello function. You see it wants a name, so we're going to pass in the text from that name box. And now when I run this, enter my name, you can see there's some output in the logs, and that was the print statement running on the server. So now we are properly in business because sure, there's limits to what you can do here. You can't compile everything to JavaScript. You can't do machine learning in your web browser or whatever. Can't connect to databases from here, certainly. But this is a real Python environment. You can do what you like. You want to connect to a database, import SQLAlchemy to Go. You want to do some machine learning, import scikit-learn. You want to process some data, import pandas. You can do what you like. In practice, of course, the very first thing that people tend to ask is, okay, so how do I set up a database? So we built a built-in database. This is backed by Postgres, so you can store gigabytes of data in this thing. It won't complain. I'm going to be a little bit less ambitious. I am just going to make a table to record all the names that get entered into this application. So I'm going to want a text column for the name that was entered. And then I'm going to add a date and time column for when it was entered. And that's it. I've just built my database. This table is apptables.visitors, and it's accessible from my Python code in exactly the same way as those text boxes and buttons were. So if I go to my server function, as well as printing that message into the logs, I can take apptables.visitors and I can add a row to it. I'm going to fill out the name with column with the name that was being passed in, and I'm going to fill out the when column with datetime.now, which I do need to import. All right, so now I have an application that is going to record data into the database. So if I enter, let's say, a couple of names, and just a reminder, this is available at hello-orlandopy.anvil.app. Audience participation is encouraged. If I go to my database, I can see this has in fact been recorded. So we've just built and deployed a web application, a database-backed web application with nothing but Python in this shorter time. Now, I'm going to go get on to showing you behind the scenes how some of this works. But before we do that, I'm going to show you one more thing, which is displaying data on the screen from this database. So we want to display all the previous visitors. So the first thing we're going to need is a server function to get them. So we'll make a callable function, get visitors. It's going to return apptables.visitors.search, which you can supply some query parameters here, but if you don't, it'll just return an iterator over all the rows in the table. And then let's go to our client-side code and display it. So we'll want a card, and on that card, we are going to put a data grid. And let's see, we're going to want a column for the name, which is going to pull the name key out of each row. We're going to want a column for when, which is going to pull the when key out of the database. We don't need a third column at all. We can adjust the widths and so on. Okay. Now, inside this data grid is a component called a repeating panel. And what this does is it has a property called items, and you can give that items property any Python iterable object. Lists, lazy iterators, generators, whatever. And what it will do is it will instantiate this chunk of UI for every element in that iterator. So what we want to do is we would just set the items property to the list of visitors we got from the server. So let's go to the init function, the constructor for this page, and we set the items property of that repeating panel to the return value of the get visitors function. And that's it. If we run this, we will see, there we go, whoever nice is, remaining anonymous, you can see we've displayed this data from the database. One last thing, this is kind of ugly, right? You can see what's happened. It's taken the when column was a date and time, so it's a Python date time object, and we've just called stir on it. And the default stir of a date time is kind of ugly. So let's go and make that display a little bit more nicely. And to do this, we're going to edit the template that gets displayed for every row. Instead of using the default behavior, I'm going to put a label into this column. And then I'm going to add a data binding so that the text of this label is set to this Python expression. And here, to be clear, self.item here is the row from the visitors table. That's a Python object passed all the way from the database to the server to here. And I can get a when column from it. And of course, this is a Python datetime object, so I can just call stirOfTime. There we go. So now when I run this, we're getting a nicely formatted date. So again, this is live. You can play with it. But I've just built and deployed a database-backed web application entirely in Python. So let's see how that works. So the first thing I should say is that this talk is not infinite in length, and there's an awful lot to this system. So I'm necessarily showing you a subset. I'm going to take you on a tour of some interesting pieces of how Anvil works behind the scenes. But if there's anything else you're curious about, you can A, ask me questions at the end, very happy to answer them, or B, it's an open source framework, so just go check it out on GitHub and go mosey through until you've satisfied your curiosity. Meanwhile, let's begin. Let's talk about something really notable there, which is compiling Python to JavaScript, because I was writing Python code that ran in the web browser, and the only thing that a web browser understands is JavaScript. So you're going to have to do some conversion to make that fly. What we do is we use an open source library called Sculpt, which is a Python to JavaScript compiler. So you feed it a Python expression, and it will produce JavaScript code that does the same thing. You feed it a Python function, it will produce, honestly, the ugliest JavaScript function you have ever seen, but it will behave like that Python function behaves. Now, it's a great project. I'll show you the web link at the end. But I'm going to tell you about the first major modification I made to it, as I'm now one of the maintainers, which is that when we first picked Sculpt up, it would do this direct translation, but there was a problem because JavaScript, in its infinite wisdom, is a 100% non-blocking language, which is to say every function must return, otherwise the browser's going to hang. And you can't sort of do synchronous I/O. And Python is a language where it's pretty idiomatic to do synchronous blocking I/O. So here's the sort of thing that it might be reasonable to write in a Python program. So, get a row from a database, do some computation on it, depend on it. Now, you couldn't do this in Python because that apptables.people.get would block. Instead, if you're doing it in querying a database in JavaScript, you have to write something like this. I count 1, 2, 3 nested callbacks there, and you might say this is unfair. I would counter that this was copied and pasted from the first page of the Postgres JavaScript API documentation. You might say that's still unfair because these days we have async await and promises. And I would say that promises are a wonderful example of exactly that phenomenon we were talking about with SQLAlchemy, which is to say, it's all just callbacks under the hood, really. And to understand how they work and to be able to debug them when they go wrong, you have to understand that this is what it's really doing when you use promises or async await. However, we're in luck because we have a Python to JavaScript compiler and it's open source. So what if we could make it translate this into this automatically? So we grab the source code from GitHub and start exploring. It turns out that the Sculpt compiler works on an architecture very similar to CPython. So what happens is you feed it some piece of Python code, and it will take it through a number of stages. The first thing it will do is it will tokenize it. So it will break it up into little substrings that are sort of meaningful subunits. By the way, these file names are the source code in Sculpt if you want to follow along. So it's tokenized it, and then the next thing it will do is it will parse and assemble what's called an abstract syntax tree. And that looks something like this. So here we have an assignment, and what we are assigning to is a variable named results, but the value we are assigning is a function call. We are calling a function named f with an argument that's a numerical constant 42. And then we have a compiler that walks over this tree, spitting out JavaScript. So clearly, if we're going to automatically translate blocking Python into non-blocking JavaScript, this is the part we're going to have to modify. So what we did was invent a new return type, because remember, this is a Python function becomes a JavaScript function, so it has to return. But what we invented was a new return type that's a class that a function can return to say, okay, I'm returning because I need to, but I'm not done yet, I'm just blocked. And we call that a suspension. And so we compile code like this into something like that, which does the call in JavaScript and then checks the return value, is that a suspension? And if so, then the function that did the call suspends itself. Let's see how that works in practice. So here is a function that when you click a button, goes and does some database access. So at the point where you hit the database access, this is what the call stack looks like. So you've got the Anvil runtime, which is handling things like button clicks. It's calling the button1click method, which is called the get method of the people table, which has gone to the database, and the database blocks. So, which is to say that that returns a suspension object. And the get function sees that it's been given a suspension object rather than a return value. So it saves its execution. So it saves its local variables, it saves its temporaries, it saves where it is in the function, and it bundles all of that up into another suspension object wrapping the original one. And button1click does the same thing. It realizes I've been given a suspension, it saves its local variables, it saves its temporaries, it saves where it is in the function, and it returns the suspension to the Anvil runtime, which then sits on it. And inside it is a JavaScript promise object. And a few milliseconds later, the database is going to get back to us. And so what we can do then is we can do a resume operation on that suspension, which is, it's another way of calling the button1click function, or its compiled JavaScript, to say, but it's saying, I'm not calling you, I'm just resuming where you left off. And the button1click function will therefore restore all the values of its local variables, restore all its temporaries, jump back to the right point in the function, and resume the inner suspension, which will restore its locals, restore its temporaries, jump back to the right point, resume the inner suspension. And at this point, the database already has its data, so it can return instantly. And so now we're back into the flow of normal execution. And that is how Sculpt turns blocking Python into non-blocking JavaScript so that you can write idiomatic code in a web browser. The website address I promised you, it's sculpt.org. Please do come and check it out. We're always looking for new contributors, and there's a bunch of exciting stuff going on there. Let's talk about another piece of Anvil that you saw me doing earlier, which was the way that we sort of seamlessly knitted that client-side code and server-side code together. And you saw that I could make a function call to a function that I had defined on the server side. And these really are shaped like Python function calls. So it's a call, it's a blocking call. You've got positional arguments, you've got keyword arguments, you've got return values. And you've already seen how the blocking part works. We actually implement this with a remote procedure call protocol over WebSockets. And the arguments and return values are encoded as JSON. Now, that's fine for arguments like these because those can be encoded as JSON. But what about values that can't? Like, for example, those database rows you saw me casually tossing around between client and server. And what we have is a system called portable classes. So what you can do is you can take a Python class and you can write that in a module that's accessible on both client-side and server-side code. And then you can decorate this class with anvil.server.portableClass. And then that way, the serializer, so the piece of Anvil that's responsible for transmitting your function arguments to the server or your return value back from the server, when it sees an instance of this class, it goes, oh, I know that this is safe to pass around. And so it will actually pass in a representation of the fact that this was an instance of my module.potato, and it will pass the dictionary of the instance, which includes sort of the value of all these instance variables. You can get more clever. If you want to control how your class appears on the wire, you can override the .serialize or .deserialized functions, methods, and fully control how these things appear on the wire. Now, that answers the sort of most straightforward question, which was, okay, I had these rich Python objects that represented database rows. How was I able to pass them between client and server? But there's another question there, because just because I returned a database row from the server to the client, and the client can now call methods on it, we don't want the client, which is, remember, it's untrusted code, it's some random visitor on the internet running code in their web browser. We don't want them to be able to access any row in my database. So we need to do some form of access control. Oh, sorry, this is just this is me showing the hierarchy of how I'm passing a piece of object all the way from the database to the server to the client. But again, to do this safely, the stuff in the white background is untrusted client code. To do this safely, you need some sort of security. And what we've implemented is what's called in computer science a capability model. The less fancy word for it is if you've got it, you can use it. So the idea here is that if the server returns the server, which is trusted code, returns an object to the client, then that was giving the client permission to access that object and call methods on it, but only on objects that the server has returned to the client. And the way that this is implemented is to bundle up an identity and some permissions. So the identity is, well, what object am I referring to? So for example, this row of this table with some IDs for the database, for the table and for the row. And then some permissions, like, okay, you have read-only access to this. And then we take those things and we add a digital signature using a cryptographic key that is known only to the server. And what that means is that when the client tries to operate on this object, when it makes makes a method call, the implementation of that method call, it'll obviously do an anvil.server.call under the hood. It will pass the capability object back with that call. And the server can check the signature. And if there is a valid signature for this capability object, well, it must have come from trusted server code, because otherwise it wouldn't have a valid signature. Here's an example of what that looks like in practice. So this is a capability on it's scoped to the database and table number 42, row number 12, read-only access. And you can construct these objects in your own code and pass them around and check them. We have tutorials on the website. And what this enables us to do then is to do some very straightforward programming that lets us not have to spend enormous amounts of our program worrying about server-client interactions. So here, for example, we are using just an if statement to control whether the client should get access to a row from the people table. So it's a server function. It takes a search name parameter, and then it checks whether a user is logged in using Anvil's built-in user authentication system, which is, I told you there was a lot I was not going to get to cover. It's really cool. I'm not going to talk about it today. There's enough to cover. If somebody is logged into this application, then and only then will it return that object from the people table. And so in this very natural way, we can do the access control. The client can call it in a very idiomatic fashion, get the return value, and then call methods on that object. In this case, it's the get item, the square bracket lookup. But it only has access to that object. It can only call those methods if the server chose to return that object. And that's really the power of a capability system. This is all the code we need to enforce those permissions. We don't have to maintain some big table of access control lists or permissions that might get out of sync. It's just the same code that controls whether the data is there and whether the permissions pass. Okay, so you've already seen me do something like this in the demo earlier, but we can do cleverer things. We can set permissions. Remember, there are permissions of the capability object. So here, this is a version of the same function, but it's returning a client writable row. So it takes app tables at people, it gets the client writable version of that table, and then searches for the row. And so the capability inside that object is going to include the permissions that say you have read-write access. And now we can update that row from the database from our client code. You can update the database from your UI code. And all of a sudden, you no longer have to plumb every operation through every layer of your stack down to the database. And this, again, enables you to build stuff more quickly. If you can securely allow client code to update the database directly, you've just saved yourself a whole load of coding. But you can do even more. Tables are themselves portable objects. So if I want to, let's say I have a multi-user application and I want the client code to be able to access all of the data records for the logged in user. So here I want all the rows whose owner is linked to Meredith@Anvil.works, so these two. And again, normally this would involve a whole bunch of access control logic, but Anvil allows you to get a client writable view. So what we're doing here is the get my records function gets the currently logged in user, and assuming that there is one, it takes at tables.records, it gets a client writable view, but it's restricted. It's a view on only the rows whose owner column is this user. And what that produces is an object that acts like a database table. So you can query it, you can add rows to it, you can delete rows from it. And again, this allows you to push an awful lot of your logic all the way to the edge, all the way into the browser without losing security. So I've talked about Python, compiling Python to JavaScript. I've talked about how we're calling functions on the server from the web browser. I've talked about how we can do that securely. And I'm going to finish by talking about one of my favorite pieces of Anvil. So this is, unlike everything else I've spoken about, this is a part of the development environment that you saw me using. You can try it yourself. It's free at Anvil.works. And this is about the code completion engine. Now, at the risk of overselling the point, autocomplete is really important if you're building a programming environment. It gives you discoverability. It lets you work out, what methods does this object have? You can just hit dot and tab and it'll list them for you. It gives you speed because you're not having to page to the API documentation the whole time. You can just hit the tab key. It gives you confidence that what you're doing is right because there are whole classes of bugs you can find and fix without ever hitting the run button because the autocompleter has warned you that the object you have isn't quite the object you thought you had. And for all these reasons, it just feels good to use. Now, if you are something like a PyCharm or VS Code user, you don't need me telling you this. If you are a Vim or Emacs diehard, that's okay. You can get Jedi, Python code completion engine, as a plugin for Vim or Emacs. And honestly, if you're not using autocomplete yet, and you only take one thing away from this talk, just try that plugin for a week. It will change your life. Unfortunately, we could not use Jedi off the shelf for a couple of reasons. One is that Anvil is full stack. So we want the autocompleter to know about your database, know about your server-side code, know about your client-side code, know about the user interface you've designed. But sure, we probably could have patched that into something like Jedi. The real killer is that the development environment is running in the web browser. And when you hit the tab key, there is just not enough time to go to the server, parse all of your code, work out the completions, and send it back to the client. And Jedi is expecting a file system, so it'd be very difficult to compile that to JavaScript. So we had to build our own completion engine in JavaScript, which would seem like a really seriously difficult task, except, of course, we have a Python to JavaScript compiler. And you've already seen how the parsing system works, and we can take advantage of the mechanisms you've already seen. So what we actually do when you hit tab in the Anvil editor is we take the module that you're currently editing, and then we feed it to the Sculpt parser. And Sculpt produces an abstract syntax tree. And then we can walk over this tree. Oh, sorry, important thing. Before we feed your code to the parser, we replace the text where your cursor is with a magic cursor symbol. And then we can walk over the AST. And we can walk in and see, oh, wait, keep us a running total of what's going on. So, well, we're in a function called button1click, and it has an argument called self and an argument called event args. So those variables must be available in the local scope. And then this is an assignment expression assigning to a variable named x. Well, okay, there's a local variable called x now, I know this. There's a call to a print function, and the argument is, oh, that's the magic cursor symbol. At which point we go, okay, well, the cursor's here, we're doing the autocomplete, but we know everything that's currently in local scope, so we can very happily offer it for autocomplete. Obviously, this technique is not limited to which variables are currently in scope. You can trace through the AST and work out a lot of interesting things. So here, what we're doing is we are looping over the result of a database search. So we're looking at what do you get when you get the look at app tables, and then you get the users attribute, and then what do you get if you get the search attribute of that, and then what do you get if you call that function, what's its return type, and then what do you get if you iterate over that type in a for loop, and then what items, what square bracket, what's available for square bracket lookup on an object of this type. But that's okay. You can trace that through if you walk over the AST carefully. And now we've got a system that embeds things like knowledge of the database here and allows you to autocomplete which columns might be available in that database row. We can autocomplete really quite a lot of things. You've already seen autocompleting the result of a function call. We also autocomplete the arguments. So here's an example. We are calling a function on the server. So we're calling this say hello function with this dictionary. And really, when we're writing our server-side code, we'd like to know what's been passed in so we can do useful autocompletion on it. So what we do is we say, I have parsed the code, parsed some code that calls the say hello function. And I know that it passed arguments of this type. And then later, when we are parsing the server function, we can go, oh, well, this is a server function called say hello. I know what arguments that gets called with because I remembered them from the other module. And we can grab that type information and stick it into the local scope, say, actually, your variable D is of this type, and then you can follow through and autocomplete it. We can autocomplete really quite a lot about Python, about these Python objects, and about various things about types, which leads to a rather philosophical question of what a type is. And you could say that, well, Python has an answer to this. The type of a variable is its class. And I mean, sort of, but Python's a really dynamic language. You can have different instances where you can add extra attributes to different instances. Heck, even something like a dictionary. These two dictionaries you might want to treat them as different types so that you can do an autocompletion like this. And so what we do is we duck type our autocompleter. We say, forget about the class of this object. We are going to treat these two maps. We're going to treat these two maps as two separate types. Obviously, they share a lot. They share their methods. They share a lot of their description. But they are two different types, and we can track them separately so that when somebody does an item lookup, they get the information specific to that dictionary. Okay. So we've seen Anvil in action. We've seen a bunch of how it works under the hood. And I would like to finish off by talking a little bit about the design philosophy behind what you've just seen. And there are two big principles that inform everything that we've built. The first is that code is good. We are telling a computer what to do. The best way to do that is to write text in a programming language. We've been doing this for about 3/4 of a century by now. And in all of that time, a textual programming language is the best way we found to tell a computer what to do. Now, periodically, somebody will come along and say, oh no, coding is terribly hard. Here, have this system where you can build a flowchart and you don't have to write any code. You can build an application. And this is a false promise. Because it's either going to be very difficult to do anything that the creator of the system didn't intend, like you're going to hit the edges really quickly, or it's going to be possible to do what you want, but you're going to be dealing with like the Cthulhu's own flowchart, and you're going to be dealing with so much complexity that it would actually be simpler to write it in a programming language. And you're going to need the same kind of computational thinking anyway. So no code is a false promise. Code is good. Get me to the code, even in that user interface example you saw. When I was displaying that data from the database, when I wasn't dragging and dropping some kind of noodle from the when column to this to the when column of the database to the when column of the data grid in the UI. No, I wrote a Python expression. And because I was writing a Python expression, when I wanted to format that date, I could just use the Python standard library because all of that power was at my fingertips. The problem with web development is not the development, it's the web. We want to get rid of the extraneous complexity of something like a JavaScript library, but if you want to define the logic of your application, code is good. Get me to the code. And the second big principle underlying everything we've built is accessibility. And if I went out onto the street, okay, maybe into a developer conference, and asked 10 people what they thought an accessible developer framework meant, they'd probably say something like, well, if it's accessible, it's simple enough for novices to pick up. And they wouldn't be wrong. It is terribly important to be accessible to new programmers. And frankly, it is shameful that we have built the web, the world's greatest application distribution platform. And then we've said, oh, no, you can't build things for it unless you know 5 different programming languages and 5 or 6 different frameworks. And I hope you're good at DevOps. That is ridiculous. Yes, absolutely. We need a programming framework for the web that is simple enough for novices to use. But that on its own isn't enough. If we just create something that's simple enough for novices, if we create a toy, a playpen, we're doing them a disservice, because today's novice is tomorrow's intermediate, is next year's advanced programmer. And if we don't give them space to grow their powers, then they will not grow. So we can't have something that's just simple enough for novices or they won't grow. And the other group of people it's doing a disservice to are the experienced professionals. Because just because I can write 5 different programming languages and 5 different frameworks to create a web application, it doesn't mean I particularly want to spend that time. And it certainly doesn't mean that my managers, my colleagues, or anybody else wants to wait for me to do it. So to make something properly accessible, you want to make something simple enough for novices and powerful enough for seasoned professionals. That way, it has the entry-level ability. You avoid this, Mount Everest and the sheer cliff face of a learning curve that the web sticks people with. But the framework can grow with them. And so they're not, we've made things simpler for them, but we haven't shut them in the playpen to do it. And it means we can help everybody from the novice to the seasoned professional. And you might be thinking, Meredith, that's a very nice idea, but come on, we live in the real world. Those are incompatible goals. And if you're thinking that right now, I would ask you to have a good, hard look at your text editor. What language are you writing? The Python language, which is the reason that we are here in this meetup, is the first language that you'll show an 8-year-old when they show up to a code club or start using a Raspberry Pi. And it is the language that powers Instagram. It's the language that powers DeepMind's latest protein folding extravaganza. It is possible to build programming systems that are simple enough for novices and powerful enough for seasoned professionals. It is possible. The very language we use shows us that it can be done. And it is only the garbage fire of modern web development that ever makes us doubt it. Thank you very much.
Well, thank you so much. Very interesting. I have a couple of questions, but first we have a couple of questions in the chat.
All right.
I'm sure people would love to know about. So the first one deals with Sculpt. Mm-hmm. And they're asking, does Sculpt only compile in ES5?
Oh, I see. You can, the generated code is ES5. The compiler itself is written in ES6, but obviously it has a whole build chain, so you can build it with the appropriate arguments. It will produce ES5. Anvil supports Internet Explorer 11 for a few more months, and then we can be rid of it. So yes, it has to support ES5.
Okay. To piggyback off of that, one question I had about Sculpt, I was looking at the languages of Python that are supported by Anvil, and I see it only currently it goes up to 3.7. Is that specifically bounded by what Sculpt is able to support, or is there some other reason?
Oh, no, the big limit is, it's approximation, obviously. Again, it's not going to be perfect. It's running in a web browser. It's 3.7-ish. Actually, one of my colleagues is currently in the process of rewriting the parser to use the new Python pgen parser that's going to let Sculpt use and compile much more modern grammars of Python. And we're going to get things like the walrus operator.
Oh, excellent. Another question from the chat. We have comparing Anvil with Streamlit. For people who are not familiar with Streamlit, it is a data science dashboarding tool, more or less. But they're asking about the advantages and disadvantages between the two.
So yes, I think the high-level answer is exactly what you said, that Streamlit is mostly a data science dashboarding tool, and Anvil is actually a significantly more powerful application development environment than that. So the UI tools and the UI toolkit is a lot more powerful. You can write client-side code, which is not something you can do with Streamlit. And just like the scalability and serverlessness and built-in database. I mean, you can absolutely do data science dashboarding with Anvil, and there's a whole bunch of examples on our website. But so you can do dashboarding with Anvil. You can't really build a new product or internal tool as easily with something like Streamlit.
Aha, we got one coming in, and I think I know what you're going to say about this one. We got Anvil working with MongoDB.
Yes, and would you like to try answering for me? What's my answer going to be?
So my assumption here, based on what you've said, is that because you're not limited to just Anvil. It's not like it's not as opinionated as, say, Django is about its ORM and database management. Is if you want to connect out to, say, using PyMongo, or I'm not sure if Anvil actually is async compatible for something like Motor, but yeah, like you would just
my two-word answer is import PyMongo. It's Python, right? What did you expect? The whole point is that you've got the whole Python ecosystem at your fingertips.
And something about the entire Python ecosystem. I do see that Anvil is one of these successful, let's say, business-based open source projects. I was going to say like corporate backed, but that's not really it. It's not something that came at it is specifically a business designed to support itself and the further of the Anvil project itself. For the entire world of Python to be available, what limitations are there if you were to host an application on Anvil's servers as opposed to your own? Because I assume if it's your own, you can put whatever you want on there. And it's like any kind of like machine learning libraries, any of the C dependencies. Are there limitations to that? Like, are you limited to only what you can pip install on Anvil's servers?
The short answer is yes. And you again guessed exactly right. If you're self-hosting, you can have whatever you like. So Anvil is, I've mostly been talking about the development environment, but of course it's a serverless hosting environment as well. The point where I just picked a URL out of thin air and the application was live, that is using Anvil's hosting infrastructure to manage, when I opened that application, some server code was spun up so that I could run my server-side Python somewhere in our infrastructure. That is part of the hosted service that we provide at Anvil.works. And naturally, in that hosted service, we can't give you infinite CPU, infinite GPUs, etc. So there is you can use most libraries, but there are some things that you can't do. Now, if you do want to, for example, do some heavy machine learning that uses a lot of GPUs, you could self-host, but there's actually an easier way. There is something called the uplink, which is a library that you can pip install anywhere in the world. And when you enable it in your application, you get an uplink key, which is a token that you can put in your code that's running on your computer, or on your compute cluster out there with 10 GPUs. And the library, the uplink library, will then make a WebSocket connection from your computer to Anvil. And the code that you are running on that computer locally, it's like it's part of your application. So you can call functions in your Anvil app from there. You can define anvil.server.callable functions. You can access your Anvil database. And so if you look on the website, a very simple off-the-shelf example we use is using this to connect something like a Jupyter notebook to a web user interface. So I can take, I think in the video, the example I do is I take a Jupyter notebook just off Kaggle with a Keras model that can tell the difference between pictures of dogs and cats. And from this stock notebook, I then go, okay, well, I'd like a user interface where someone can take a picture on their phone and upload that, and it will give you the model's answer. And I put a user interface in there, use the uplink to connect that notebook to that user interface, and then use that UI using the code that's still running in the notebook. So that's our classic recommendation. If you have something that's extremely something like CPU beefy, GPU bound, then take the code that you really need to execute in a particular place on particular hardware, run it there, use the uplink, and then do it. You can do everything else in Anvil and still have it all integrated.
Very interesting.
I wasn't kidding when I said that there was stuff. There was a lot of cool stuff I didn't have time to talk about today. The uplink could be a whole talk all on its own.
Yeah, I hadn't heard of the library, but it sounds very useful, both with and outside of Anvil itself.
Yep, indeed. I mean, we've got people using it for all sorts of things. I mean, IoT is also great for that because you can just have code on a Raspberry Pi that you can call from the web front end, which is insanely useful for prototyping stuff. There is a button somewhere on the internet, for example, that will cause every speaker in my friend Ian's house to play the chimes of Big Ben at full volume if I push a button on a website. Really important, serious uses like that.
It's those really serious, important uses that get us out of the gate.
Mm-hmm.
All right. I don't see any more questions coming through in the chat, but I have one question or a look to the future, if you will. Yes. I remember Russell Keith McGee's talk, keynote at PyCon in 2019 or 18 about Python black swan moments. And Anvil seems right there in the sweet spot when it comes to the future of web and WebAssembly. I know that Sculpt is not WebAssembly. It's transpiling the Python code into JavaScript, which is not quite the same. But I'm wondering if there is any look or research being done by Anvil and your team in that direction. Maybe not as far as, say, the Beware team is doing, but anything looking towards Python actually running in a browser.
So, okay, all right. So when you say Python running in a browser, okay, rewind. Russell's talk was about like black swan moments for Python, as in what would knock Python off its perch, and one of the answers being actually the web becoming the place where everything happens. And if you're considering this some sort of tribally from within the Python community, that is considered a threat. I'm afraid that my background originally doesn't lie inside the Python community. I regard that mostly as a threat to the ability of developers to get their work done without completely losing their minds, because the platform used by the web is so user hostile, and using Python was an opportunity to make that less hostile. So we come at this from slightly different angles. And so I suppose from my point of view, using Python in the browser is sort of a means to solve a problem. I am not, it's odd given that I'm a maintainer of a full stack Python web framework. I'm not sort of a Python maximalist who believes that everything should be in Python as a general moral principle. I mean, you saw the diagram with the blue and orange squares. The challenge was to find a representation that works all the way up and down the stack, and Python happens to work really well for that. But there isn't a religious requirement to have CPython and precisely CPython running in WebAssembly in the web browser. The requirement we're working towards is the developer experience of being able to build applications without having to use 5 different representations for all of your data. And for us, for now, in Anvil and in the Sculpt project, the compiling Python to JavaScript is actually fulfilling that just fine. If you need something that's only available in CPython, that's fine. The server-side code is only in anvil.server.call away. You can do what you like. There are projects like Pyodide, which I assume you've seen, which is running a full CPython with a whole bunch of the data science suite in the web browser using WebAssembly. And that is a really amazing achievement, but my goodness, it chugs a bit when you're starting it up because you're loading all of that code. It's sort of cross-compiled in this weird kind of way, and then your browser is sort of bytecode compiling all of that. And, you know, on my machine, PyDI, last time I checked, took about 20 seconds to start, which is absolutely fine if you're using something like a notebook. But if you're building application code, you know, you're building something that's consumer-facing that needs to respond in 100 milliseconds, that approach just isn't going to fly. You know, we'd be up for WebAssembly as a way of accelerating Python in the browser. We're kind of technology agnostic on that one. I have not actually been following what Beware have been doing on this front. PyDI, the project I've been watching, but I'm interested to see what happens. But fundamentally, we are not chasing an arbitrary goal like, oh, it must be CPython in WASM in the browser. It must be a good developer experience. And the only way we could think of to create a good developer experience is some way of writing good Python in the browser.
Absolutely. The phrase "done is better than perfect" came to mind during that, and absolutely something you can use right now to get something done is definitely going to be better than something that oh well we're still thinking about it and we're still making everything.
Well, and also, I mean, perfect, like something like PyDI is perfect in that sense. It's got all the libraries, but there's a trade-off. It's very heavyweight to load, and you know sometimes you just have to pick a different point in the solution space. Something I should plug, by the way, is a colleague of mine a couple of years ago wrote and gave a talk at PyCon UK actually about comparisons of the various Python in the browser frameworks. He's referring to an old version of Beware's project. It's possible that post now needs updating, but if you Google like Anvil Python in the browser, you will find the page where we have the YouTube video of the talk and also like the blog post style write-up of it.
Very good. Oh, we just had one more come in. Is there any movement toward offering Anvil to educational systems that are more piecemeal? I'm going to need some clarification
there. So I think the answer to your question is that Anvil is already free for classroom use. I mean, okay, let's start with, if you are using the, obviously, if you're using the open source thing, then it's open source, do what you like. If you're using our hosted service, everything I have shown you in the demos and the walkthroughs today is available on our free plan. So you can absolutely rock up and start using it. And there are a whole bunch of educators who already use Anvil on that basis, just on the free plan. Having said which, if there is a feature that's part of one of the paid upgrades that you want access to in a classroom environment, just drop an email to education@anvil.works and you'll get a free license, no problem.
This is Fred. I posted that question. What I've been running into is so many of the various both colleges and high schools are teaching parts of what Anvil offers as a whole. And so you can learn HTML, or you can learn JavaScript, or you can learn database. But is there any crack in that dike to teach the concept? This is really more how to think like a computer scientist as opposed to language syntax. I love it, but I've seen a lot of resistance.
Absolutely. We have teachers doing that, and it absolutely kills me that this talk is recorded, so I cannot mention the name of the large organization that is producing classroom training in exactly that sort of thing, in that kind of teaching, thinking like a computer scientist, using Anvil for exactly those reasons, because it lets people learn about the ideas of, oh, this is client versus server code. This is a database. This is a web application. It lets you use all of those things without having to drag some high schooler through, you know, however many months required to get all that language and syntax stuff that they will need to understand, that, you know, to even attempt a concept like client server in the context of traditional web applications. So yes, absolutely. It's a great way of getting people sort of naught to okay, this is a full application, and now we can explore some of the actually interesting concepts rather than spending every lesson you have this year trying to stuff syntax into your head. Oh, by the way, sorry, I should say that my my email address is visible on that slide. I'm reddit at anvil.works. It's also, you can Google for me. I'm plastered all over the internet. I'm also my first name on Twitter. So please do, get or stay in touch.